Rational expressions, multiplying and dividing. Let's do a simple example here. 2 over 3 times 5 over 7. Here, to multiply fractions, we multiply the tops. 5 times 2, which gives you 10, over 3 times 7, which will give you 21. That's the basic idea. Multiply the top, multiply the bottom. But there's a lot more to it than that. Of course, if you had a problem that was like 10 over 9 times 3 over 5, and, well, we can multiply the top and the bottom, but we would have to reduce. It'd be a great thing to reduce before. So in this case, we can reduce up and down or across. 5 goes into 5 once, 5 goes into 10 2 times, 3 goes into 3 once, 3 goes into 9 3 times, 2 times 1 is 2, and 3 times 1 is 3, is 2 over 3. So let's do a two rational expressions. Let's say 18 over x cubed times x to the 5th over 15. And when we multiply rational expressions, the whole idea is you need to factor, then cancel, then multiply. And we do that because we want to, not do so much work in the end in reducing. Here, what happens when we multiply these two rational expressions is the variables, these x to the 5th, x to the 3rd. A lot of students can't see that. So what I'm going to do is I'm going to do it this way for this problem. 18, now x to the 3rd has 3 factors of x times x to the 5th has 5 factors of x, 1, 2, 3, 4, 5, divided by 15. And now I need to reduce. If I know my multiplication tables, I know 3 will go into 15 very nicely, 5 times. 3 will go into 18, 6 times. And I can see that I have 3 factors in the bottom, 5 factors on the top. I can cancel 3 in the bottom, 3 in the top. When I cancel 3 in the bottom, I put a 1 there. And this one is really x squared. Okay, 6 times x squared is 6x squared, divided by 5 times 1 gives you 5. Let's try the next problem. X squared minus 16 over 8 times 2 over 3x plus 12. All right, so this is more of a traditional rational expressions multiplying type problem. These type of problems you have to factor, and then you have to cancel and multiply. And we do that so that we don't have to reduce in the end so much. Usually you don't have to reduce anymore. So here we see x squared take away 16. That one we can factor. It's a difference of squares. So we have an x, and one's going to be plus, one's going to be minus. 16 square root of 16 is 4. Now if you don't remember how to do that, you should always watch the video on how to factor. Okay, multiply 2 over, and this one here, I know that I can also factor it. I can take out a 3, factor out a 3, x plus 4. And you can see 3 times x is 3x, 3 times 4 is 12. And you'll notice now that we have x plus 4 as a factor, x plus 4, this binomial. So I can cancel that. One's on the top, one's on the bottom. This 8 and that 2 I can cancel. So 2 goes into 2 once, 2 goes into 8 4 times. And now I can multiply. X take away 4 times 1 is going to be x take away 4, divided by 4 times 3, which gives me 12. A very classic problem where you have to factor and then cancel and then multiply. The big pitfall for rational expressions, when you multiply these rational expressions, is the factoring part. All right, let's try division problem now. All right, let's try the next problem. X squared plus 7x plus 12 divided by 10 divided by 2x plus 8 over 4. All right, we can see that it's division now. And when you're dividing rational expressions, you might want to use the KFC method for keep the first fraction, flip the second fraction, and then change. Change the division to multiplication. Let's do that. So we're going to keep the first fraction here. Okay. I'm going to flip the second fraction. All right. And then we're going to go from division to multiplication. Now, let's see if we can factor. I think we can. This trinomial we can factor. Now, if you forgot to factor, go back to the videos and find out how to do that. But it's not too hard. 12 can be broken down into 4 times 3. So I'm going to put a 4 and a 3 here. I know this is a plus. That's a plus, and that's probably going to be an x. And so 4 times 3 is 12, and 4 plus 3 is 7. And then we're going to multiply. We'll write the 10 out, of course. And 4 divided by, usually if you factor one area, you're probably going to have to factor another. And I can see that I can factor out a 2 in this case. 2x plus 4. Let's see. 2 times x is 2x. 2 times 4 is 8. And you notice that x plus 4, this binomial, this factor, is on the top and also on the bottom, so I can cancel. What else can I cancel? Well, 2 goes into 4 2 times, and 2 goes into 2 once. What else can I do? This 2 and this 5, this 10. So 2 goes into 2 once, and 2 goes into 10 5. All right, so x plus 3 times 1 gives you x plus 3 all over 5 times 1, which gives you 5. All right, let's do the next problem. X squared y to the 5th all over 8 x to the 4th divided by y cubed all over 4 x to the 3rd. Okay, so if we do the KFC rule here, we keep the first one, x squared y to the 5th over 8x to the 4th. So we keep the first fraction. Flip the second one, 4x to the 3 over y to the 3rd, and then change from a division to multiplication. Okay, and to make it a little bit easier, right, we're going to take x squared and y to the 5th, and we're going to write out the factors. So x squared is really x times x. Y to the 5th is 5 factors of y. 1, 2, 3, 4, 5 divided by 8. X to the 4th is 1, 2, 3, 4 factors of x. Multiply. 4 times, how many factors of x cubed do I have? I have 3 of them. Divided by 3 factors of y. All right. This is just to make it more visual for certain people that can't reduce variables. Okay. So let's see. 4 goes into 4 once. 4 goes into 8 twice. I have 2 factors of x on the top, and I can cancel 2 factors of x in the bottom. I have 2 factors in the bottom and 3 on the top, so I can definitely cancel out 2 more. Okay. What else can I cancel? It seems like I have 5 factors of y on the top, 3 factors on the bottom. Let's cancel these 3 factors of y. I'm going to put a 1 here. I'm going to cancel out 3 factors there, so I'm left with y squared. And there we go. Y times 1 is y squared, and 2 times 1 is 2. And we're done there. So when you multiply or divide rational expressions, don't forget to factor, cancel, and then multiply. We do that so we won't have to reduce after we multiply or divide.